So hello everyone. Welcome to the 74th edition of Silesia JUG. Today we have a pleasure to host Sven Ruppert. Sven will talk about functional reactive with Core JDK. Hello, Sven.
Hello, hello.
So before we start, I would like to mention our sponsor, Silent8. Thanks to them, the streaming is possible. Silent8 builds the anti-money laundering system. They do something meaningful for the society, helping stopping financial terrorists, fighting money laundering. And if you want to know more about the company, feel free to ask me, as I'm privileged to work in Silent8. Besides that, we encourage you to send your talk proposals. We are constantly looking for new speakers. So if you actually want to do it, just go to silesia.jug.pl and go for the link, apply. So this is it, I guess. So now I would like to invite Ari with his slides. Thank you.
Yeah, thank you so much, Marcin, and thank you so much for having us here today. Let me go ahead and share my screen really quick.
Thanks.
Let's see here. And now what I wanted to share went away, so let me pull that up again. Please forgive me. But here we go. Can everyone see it okay? Let's see.
Now it should be okay.
Excellent. Awesome. Well, thank you again for having us. It's such an honor for us to be here today with your community, with your Java community. My name is Ari Waller, and I am the Meetup event manager for Jfrog. And we just are really, really excited about being here today in Sven's talk. I'll just share just briefly about who we are, as we have a couple of special things we want to give to your community. One is a little bit about Jfrog. We are the DevOps software company founded in 2008. Many people in the DevOps community know us best by our flagship product, Artifactory, which was written in Java and is considered by many to be the gold standard for managing your artifacts and dependencies. But we do have also, especially for the Java community, a free cloud version of our software available for you. It is not a trial version where you suddenly become a customer of any kind. No, it's actually your free version of our DevOps products for you to work with and play with for your project. So we're excited to offer that to you for free, and you can use that with the QR code. And I'll drop the link in the chat afterwards. But the other item we are excited to offer you today is a raffle. For those of you who would like to have a pair of Apple AirPod Pros, we will be giving a pair away to one of the attendees in today's meetup. And basically, by clicking the QR code with your phones, I'll drop the link in there as well. You can enter the raffle. Now, we don't do live drawings because of corporate compliance purposes. However, within 3 days, I'm going to email the randomly selected winner. And once you accept the prize formally, we will share the name of the winner with the entire meetup community. So we like to bring some joy wherever we go, even if it has to be virtually. And I just want to thank you again, Marcin, for allowing us to share with you today. And without any further ado, I'll turn it back over to you and Sven.
Yeah, thank you very much, Ari. And I think, Sven, the stage is yours.
No, thank you very much. So, yes, welcome from my side as well. So, and what we are talking about today, functional reactive with Core Java. So, yeah, I'm not sure. I think I can see here some comments that are coming from the streaming platform, but I'm not sure if I can write something to you in the chat. So that's all. So, but if you have any questions, let me know somehow, and then we will be able to, yeah, give some answers. Okay, so functional reactive with Core Java. So as you can see here, it's from Java 8 until now Java, I don't know, 700 and 400, what we have right now, I don't know. And so what I'm showing here is stuff that you can use, yeah, since JDK 8 and beyond. So let's start. So now I try to find out how to click my slides forward. Oh, it's working. Perfect. Oh, yeah, by the way, my name is Sven and I'm working for Jfrog and I'm a developer advocate there. And if you want to see some videos from me, from talks or whatever, then check out my YouTube channel. I have it in German, I have it in English. This one here, this Auto-Nerds, this bit.ly link is the English one, but inside my YouTube channel, you'll find all the other links. So, and if you want to have just bushcrafting stuff, so where I'm going to the forest and doing some random stuff that has nothing to do with IT, well, check out my private YouTube channel. Huh? So yeah, there's the German one, the other one, then you can see I linked the other YouTube channels there. So it's since the pandemic, I'm doing this one because I can't travel, but maybe if the pandemic and all this stuff is going away, then why not coming to your JUG, huh? So then we can have a live coding also. That would be cool. Okay, I think I already mentioned it. This is this pair of Apple AirPod Pros. Oh my God, it's such a long name. So just go to this URL and yeah, try to get your ones, and you will find slides, by the way, there as well. So let's start. Functional reactive. It's a broad topic, it's a big topic. And the big question is, if you're talking about Java is an object-oriented language. So where the border between object-oriented and functional, and then functional reactive. So, and I'm not at the university. I'm not teaching stuff at the university. So I'm just looking at the whole topic in a more practical way. So as a regular developer that's just there sitting with an IDE and thinking about how can I use functional approaches or functional paradigms inside my Java language I'm coding with. So, and I'm not comparing with Kotlin, I'm not comparing with Frege or other languages that offer different functional semantics. I'm just focusing here on the core Java and on a practical approach and not on this academical approach. So the pure whatever thing. So that's not what I'm talking about. Okay, so if you're looking at this one, we have since Java 8, it's long time ago now, different possibilities to formulate or to express things, and where it will start with functional. So quite often I see that other developers are talking to me at conference or whatever and saying, oh, function is just if you have lambda expressions. And I say, well, lambda expressions, it is some kind of true that it's supporting the functional language, but it is not the only way to write functional. So even previous JDK 8, you can use functional paradigms and can code in some kind of functional way if you're merging or transferring the functional ideas to the language specific possibilities. Okay, so using lambda expressions means that you're coding functional? No, definitely not. If it is helping to code functional, yes, it is. If you're using method reference, is this functional? Some kind of, but it's not using method reference. Now you're coding functional, so you can use it in object-oriented way. So it's just a syntactical thing. Okay. If you're now reducing this lambda expression and writing it with the lowest line here, new function and so on, is this now less functional? I would say no and yes at the same time. It depends what you're doing. So how are you doing it? So you have different paradigms you should thinking of, and definitely the border between object-oriented and functional reactive is not clear in Java, and this must be true. And all discussions around this is not 100% functional. These discussions are useless. It's at least my opinion. Okay, so just as a short recap, I think the most known functional interface, this is just a marker, nothing else, and it's functional interface if you have just one method to implement, one method signature, and if you have this default implementation, then it's not a functional interface anymore. I'm repeating this one now since I don't know how many years, and quite often I'm touching developers in a way that they know it somehow, but it's not always present. So you have to think about it. Why I mention it, because if you want to have a functional style API, and we're dealing with inheritance, for example, because Java will give you inheritance, but it's not part of the functional world. So you have to make sure that some paradigms from the API and from your way to describe your API is not bleeding out of this thing you want to describe. Okay, so just a short example, we have this 3 interfaces and 2 classes, and there's the inheritance. So I have this interface A and I have interface B. Interface B is extending interface A, and class A is then extending interface A and B, and the same with class B, it's extending interface A and interface C. So let's have a look here what's going on, just to have in mind what will happen if you're not very clear and strict with these definitions. So this interface A has not 2 things. It has now a default implementation and a static method. By definition, that's not a functional interface. And you see that the static implementation or the static method will have an implementation. So the static one is called do more, and the default implementation is called do something. Okay. So now I'm creating the interface B, that's extending interface A, and I'm overwriting the method do something. Okay, I'm just declaring the same. So who's now the winner in terms of implementation? If you now inherit from interface B, then the implementation do something that is with the default implementation in interface B, that's the winning thing. So now I'm creating an interface C with exactly the same method signature and the default implementation. And now I have 3 default implementations for the same method. And now I start combining this stuff. So with class A, I'm implementing interface A and B. What will happen is that the type interference and the if you're dealing with inheritance, it will implement it in this way, so you don't have to write anything else. And the implementation that's winning is from interface B, because it's the best specialized one. If you're doing the same with class B, you're implementing interface A and interface C. Now they have this colliding method signature, and the compiler will immediately say they are on the same inheritance path, so they're on level. So he can't decide A or B, and then it will break the compiler and will say, okay, you have to decide, you have to do it. So with this, we're not able to make this diamonds, this inheritance diamonds. But on the other side, if thinking now about function is pushing abstraction to the limits. I will explain this a little bit more in detail in a few minutes, but pushing abstraction to the limits mean that the tiny pieces we are creating, they are very generic, and with very generic means they will have very generic names. And I see quite often that if you're designing APIs and if you have very generic items in, then people tend to use generic names as well. And then I saw in a few projects already that independently they choose the same name of methods, sometimes even with the same signature in terms of parents. And then it was leading to some kind of mismatch here, and it was breaking the API. Why I'm doing this with these interfaces, I will describe in a few minutes, why I'm focusing on interfaces here. But there's another thing that is sometimes not they are not thinking about it. It's inheritance of static implementation. So you have this interface A with this do more, the static method do more, and what you can't write is this implementing class is class A dot do more. You can't write it because it's just breaking here at this point. You have to go back to write interface A dot do more. And this means if you have now a complex hierarchy of interfaces where you're putting letters, default implementations of methods and all this stuff in, we are coming in a few minutes to this, then this detailed information about the internal structure is bleeding out of your API, and you need internal knowledge to do all this static imports and all this stuff so that you're getting rid of this stuff. So have this in mind if you're designing APIs in a functional way. Why? I'm explaining in a few minutes, but just this as a recap to make sure that we are aware of this one. So, and then if you're just calling this one, just as a heads up here, or to remember, this was inheritance tree. And if you're calling all this stuff, then the first do something is calling interface B, so the most specific implementation. And on class, the method on class B do something is using the interface A implementation, because the other one has nothing, or better, we decided that this is one because we had to implement it, and do more is just the static output from the static method. Okay, so if you have this one, we got over the different JDKs, different enhancements. So for example, with JDK 9, we got this private methods, and with private methods, we can just split up default implementations, and it's available since so long. And if you're already on LTS version like 11 or whatever, then I see that quite often huge default implementations are available, but they are not using private methods in interfaces. So we have this long code blocks instead of breaking it up. So I don't know why, but it's still some, I don't know. And you can do the same with private static methods. And this I'm seeing not so often. So even this you can do. You can share implementations between different things in a private state, okay? Okay, so the first thing, if you start thinking about the way of being functional, means that one of the sentences is you're not dealing with a value, you're dealing with a holder. Why? In a functional world, you want to get rid of null and giving a null back, or throwing an exception because you have no value and all this stuff. And the optional was the first approach here. There are some limitations, and I will explain why I don't like optional and what you can do. But so far we have this optional. So if you're there, then you have something like an empty optional. Okay, you have a replacement for null is an empty object. You have this optional of a value, and this is typed with this stuff in. But if you have an optional of null, then it's not typed anymore. So how to deal with a type if you don't have it in this way? So, okay, just make sure that your type interferencer, if you're dealing with this, is always clear and strict, and test it. Yeah? Okay, since Java 8, we have this is present. Okay, you can ask if something is in, because if you're just grabbing, the most of you know, it's just throwing an exception. And with 9, we got streams, and with 10, we got additional methods. So this optional is growing. And that's nice. You have more and more ways to play. For example, if you want to split up branches, so in the functional way, I have a value, yes or no. If I don't have a value, what should I do? With the optional, you have the first possibility to branch between things, so that you're declaring if something is available, do this. If it's not available, do something else. But it's just stopping here at this point. No? So if present or else. And you can use method reference as well. So this just syntactical stuff, so that you are dividing the value and the transformation. And that is something we are covering in a few minutes very detailed with functions. So in an optional world, you make sure that you have just the transformation itself. It should be independent from state, from something that's out. So really just this transformation, this atomic operation, and it's happening or it's not happening. And you have to have in mind that if it is not happening, you have to recover the state in a way that is dealing with Java again. So that's one thing. And there is one thing, this or else throw. I don't like it because it's breaking the functional world with throwing an exception. It's there, but I think it's not good to use. But there are, oh yeah, and by the way, if you have an optional, you can use this transformation chain in terms of using this map method. So you have a transformation, you have the value, and then you're adding one transformation as another, so that you have this chain of transformations, this functions, and then you're transferring or you're transforming the values step by step. If you have just a single value, it's easy. If you have no branches, it's easy. So that's an easy way to go, and you can just go with optionals. You have to make sure that you're using map and flat map in a way that you're not creating this optional of an optional of an optional. But so far it's okay. So if you're just transforming a value in with a chain of transformations, you can go with optional. The option itself will give you this throwing method. I don't like it, so I would say don't use it. Okay, and now we have different things to think about this optional. Why this is not functional enough? The optional itself is not symmetric. Means you have the method if present, but you don't have, since JDK 8 the method, it's not present. So you have always to do this if present, not do something else. So that's one thing. And this is for all the methods. So if you have something, it's always good if you're designing functional API that you're not only designing the positive way, but design the negative way in the same way. So always make sure that it's symmetric. For the functional reactive part, the option itself has no connection to the reactive world. We have reactive stuff in the JDK. Why this option is not really supporting it with the map methods and flat map methods. So that's one thing. So it's always blocking. For me, it's not functional enough. I will show it in a few minutes. And the bad thing is we can't change it because it's declared final. There is no inheritance possible for fastware, so we can't extend it. So it has something to do with value types and all this stuff. They're increasing later in the JDKs. So, but this was an excuse to make it final straight from the beginning. Okay, so we need something, but we need something that fits inside the core JDK and with a minimum effort we can have. I call this stuff now result, just to have a different name so that we don't have the same name of this. So it must be easy if you start dealing with value holders. It must be easy to transform from optional to something you're creating, in my case result, and reverse, so that you have this minimum glue between your code and other code, the same way with optional code as well. So it should work as a drop-in replacement. So I see so many functional libraries that are building their own stuff in a very aggressive and maybe even more functional way, for sure. And they are good implementations. I don't want to say something against them, but if you're using something like Java slang, or I don't know what's this actual name of it, yeah. Okay, if you're using this one or some other functional implementations, you have this whole own data types and stuff and all this stuff, and then you have really to transfer into this framework. Then it can work inside this framework, but in the moment you want to go out of this framework or out of this library, you have this ugly wrapper place. And if you need to get rid of this one later, because we have now this functionality in Java itself, it's very hard to get rid. So make it as a drop-in replacement. Yeah, Fav, right, Java slang. Thanks, Mirek. Thanks. That was exactly the name I was missing. Okay, so it should be in an easy replacement so that you can make it as a drop-in replacement. So if your implementation is covering something that will be implemented later by the JDK with the same functionality, so that you can just easily switch back to the core JDK so that you are getting rid of your own implementation. Everything you're not writing by yourself, you don't have to maintain. And it should be always a good advice to reduce or go back to the core JDK implementations. So I think it should connect to the reactive world as well, because we have this part inside the JDK, and that's just nice. And it should be symmetric. Symmetric is so that you're always defining the positive and the negative way. That's really, really necessary. The most forgetting, they are so excited excited about the functional world, that everything is functional, and they try to get all the colleagues around to get excited about functional, and be sure that's not always the case. Function is not better than OO. OO style is not better than functional. So both have their plus, the plus and minus points. But mostly in projects, you need, if you want to code in a functional way, you need the way that this API you're creating could be used in an OO style somehow as well, so that you have this low barrier, that you can smoothly make this transition from my module, what I'm writing in a functional style, to the OO style that is used by my colleagues. And it's mostly making transitions easier and more smooth, and all the political stuff in the background as well. So, okay, so transferring from and to optional is quite easy. You have in your implementation something like to optional or from optional. By the way, all this stuff I'm showing here is on GitHub. It's called Functional Reactive, and it's on my GitHub organization called Sven Ruppert. There you will find all the implementations with Jessica Rich as well, for sure. And then if you have this to optional and from optional, so that's just one call to transfer, then you need, for example, not only a positive thing, but a negative thing. And the difference here to the optional is, if you have negative value, then you have first of all just a possibility to wrap a null. Okay, so you have nothing. And typing, as I mentioned, is sometimes tricky if you're dealing with null inside this optional world. So it must be type safe. On the other side, you need information about what was going wrong. Later, if you're discussing a little bit the exceptions part, you need, for example, the exception method, so that you can do something with it. You can log it, you can analyze it, you can whatever. So you need some kind of information. And for this, you need the possibility to add a string, the information itself, but it must be the old type. And this you see here with the result of failure. You can write your message, but you can type it in a way that's still fulfilling the old type, so that it's easy to deal with the type interference. Okay, the next thing is this symmetric part. So if present, this is what we have with optional, but I added immediately this if absent. If this is in a later JDK added, then you can switch it. Then you can just go back to the optional if it's necessary. Yeah, but so you can just say if absent, do this, if present, do this, and you don't have this interaction. And the same for both ways. If you want to deal in both directions with success and a failure, and success is a value, the typed in a way that you have this original type, for example, an integer or whatever, but failure is typed as a text because, or a string, because you want to deal there with a failure message. And this is important with if present or else, so that you have both things available, but correctly typed. Okay, connecting to the asynchronous world, this is the last part of this talk, this reactive part. You should have all method signatures with a prefix or a postfix, whatever you like, that is giving you the same functionality in a reactive way. If you want to go to functional reactive, and here it would be just if present or else asynchronously. That's it. Okay, so so you can decide if you need an asynchronously or not, if you need it blocked or not, and this will give you the freedom to choose pure functional or functional reactive, but it's there, but you don't have to use it immediately and all this stuff. So it's smooth for transitions. Okay. Combine it with value and transformation. So what I'm missing a little bit with optional is the optional has this map method, and then you have just the value and you have the transformation, and then there is no way to combine two streams. So you have a value, now you want to combine, you want to add something to this transformation, and then you can use this this method name is stolen from the reactive part, so then combine from completely future. But I'm using the same name so that people that are common or fluent with completely future will immediately see what is the meaning of it. So I'm trying to use mostly this JDK naming schemas, mostly, not always. And then you have this possibility to have this result and combine it with a value and with a transformation. And this means you're providing the value and you're providing just a transformation, because the transformation should be always stateless. We're coming to this with the function part in a few minutes. So now we have this combine, and again, make it synchronous and asynchronous. If you want to go to the reactive part as well, then combine asynchronously. But you're in both times just pushing exactly the transformation and the next value. Okay, so if we have this, we could think about what can we do instead of using plain values. And this is one thing that most people are, it needs some time to get used to this idea. So if you're dealing with a functional thing, you have a value. Most people are thinking about an int, a string, whatever, an instance of a class, but a function, an instance of a function is a value as well. And this you can combine with another function, or you can transform a function. We'll do it in a few minutes, but just as an idea, it's not only a string, a value, it could be a function as well. And then you can combine function. It could be done in an asynchronously way if it is needed, and so on and so on. Okay, so just have in mind, an instance of a function is a value itself. It could be a value. And then we can start expand the thing of just having a scalar value and then transforming. Now, if a function is a value and a function can transform a value, then we start playing around with a functional approach. Okay, what can we do with this? Before we are going to this, I want to cover a few typical things like exceptions. Exception is one thing that is mostly not fulfilling the functional world idea. So there's something going wrong and throwing an exception and the JVM is blowing up. No, in a functional way, the approach is that you're catching exceptions as soon as possible and then do something with it. So don't throw an exception, catch the exception everywhere, but then do something useful. So here, if I have this parse int and I'm pushing some random stuff in, it will give me a number format exception. Okay, I have a print stack trace. So what should I do with this? I can do it with a stream in the same way. So if I have different values and in the middle, there's just a crappy value, I have this map to int, and again, I have an exception. So how to deal with this? With streams, I saw so many times that people start using this try-catch block. Thinking about functional approach means pushing abstractions to the limit. Means I try to identify patterns and try to describe them in a mostly or in the most generic way so that I can combine them freely with all the other functions I have. Exceptions is a good example. So what I see is quite often the stream, map to int, and then try catch internally. And the bad thing here is sometimes they start returning a stupid value like a null, or this zero, not a null, a zero. And what should I do with this print stack trace? This information is lost or just locked. And then I'm giving back a value that's part of the possible values. It's not good. If it is just a sum, it's not changing the result. But the next evolution that I saw was mostly this map, then try catch. And during the map phase, they wrap this stuff in optional. But again, what they are losing is the information, this print stack trace stuff, for example. But then you have this construct of try, catch, filter, map, and so on. Or if you're using a later JDK, try catch, wrapping to an optional, flat map, the stream, then you're getting rid of all these optionals as well, and then mapping this one to whatever you want to do. So this is boring code that is just unbelievable, bad maintainable code. And if you have this in a bigger chain, then it's just a lot of noise in your code. So how can we make this a little bit nicer? Thinking about a checked function. A checked function would be something that will allow you to throw an exception. And then inside this map phase, you would have a checked function from type A to type B with a method apply with exception. The value is going in. You're doing whatever is necessary. You don't write this try catch block because it's possible that this exception is thrown, and then you're dealing with this. You see here in this flat map method that I'm giving back a result up. So this checked function is more or less, if you are looking at it, so the lower implementation is just without the syntactical stuff. No? So you see map, then you have exactly what you want to have with this typing stuff, and then the short thing. What I've done here is just the checked function is nothing else as extracting the try catch block and with this typing, with this optional stuff. Okay, I'm typing it to the result because I have the possibility to make it from the syntactical point of view way more smooth. But what I have is here, this checked function is overwriting the apply with exception or implementing apply with exception. Means that the original checked function can be converted back to the core JDK functions, a function from string to result of target type. How it looks like. The checked function is a functional interface because I want to have exactly this lambda expressions, and it's extending a function from type T to result of R. So I have there this wrapping so that I can deal with null. If I'm wrapping it to result, I can catch the error message, and I don't have this boilerplate code, and I can use lambda expressions. Great. So now I have a functional method or functional interface, and I'm giving a default implementation for the original apply method and defining an apply with exception. That's it. Now I can use it like a normal functional interface, just having in mind that you have this type mapping from type A to B to type A to result of type B. If I have this method, this checked function, immediately I have a checked consumer as well, because a checked consumer is nothing different than a checked function with a transformation from T to void, but I'm still holding the information, what is going wrong. I have a checked executor as well, because the checked executor is something that is a function from void to result of void. It's just executing something. And I can write it in the same way, okay? I can have a checked supplier, because a checked supplier is nothing else as an extended supplier that is wrapping the type, because if the source is having an exception, then I need this information and so on and so on. So it's always the same thing. So what I've done here now is that I have now the possibility to work with lambda expressions and extracting the pattern of catching exceptions and this wrapping stuff. So, and this makes a lot of stuff very, very condensed. It makes this syntactical stuff very clear. So I'm extracting noise with extracting the exception handling. And I'm making sure that exception handling is everywhere the same. And I'm just using this core functions or this core interface. So the implementation of this, just a few lines of core Java. Talking about functions, a function is a transformation. So from input value to output value. Okay, everybody heard it so far, but it means one input value to one output value. That's it. Okay, and an input value will have the input type and the input value. So we have two informations, the value and the type itself. Dealing with inheritance, this can be a little bit tricky in some points. Okay, so let's assume we have this function integer in and integer out. We're adding something. And here we are constantly adding the value 2. Don't ask if this makes sense. It's just an example, okay? So we have this type, and we have this transformation. Let's assume we have different functions defined. We have to add 2, and later we have to add 10, and at several places we have to add 5. Now I have different questions. First of all, what is the right place to define this function so that if later, if I'm using the possibility to add 2 at a different place so that I can use the same definition of this function. So where is the right place to store this definition? I see so often it's just near the code, I'm defining this function, I'm using this one, throwing it away. And in different place, I'm doing exactly the same. Okay, makes no sense. And pushing abstraction to the limits means I have to think about what is repetitive, so what's repeated and what pattern I can extract. Let's start with the first one, how to combine functions anyway. So I have to do function A, function B, function C. Here it's very easy because it's always from int to int. So the first thing, or the object-oriented approach of using functions I'm seeing so often is I'm applying the function, I have the value. I'm applying the function B and I have a value, and so on and so on. And then they start combining or concatenating this function. So function A apply with a result from function B apply from the function C apply. This is an object-oriented approach. Yes, I'm using function, but this is definitely not functional approach. So how to deal with functions? Theoretically, it is in a way that if you have different transformations and you have an input value that's going along all these transformations, you can convert these transformations to one transformation. Makes sense, because then you have all stateless parts combined to one stateless part, and then you have the value, calculating it in output. Okay. For this, we have two possibilities in Java. One is good and one is strange, or not so good, let's say, because we have a typed object-oriented language, so we have to deal with inheritance and all this stuff. Let's see. We are coming to this. So there's one thing that's called compose. I can compose functions, and this is that I'm using the function before, applying this one, and using this, what I calculated right now, as input for my own function. So apply what's happening before. So what's going on here? I have a function, and this function is transferring something, so input type and input value. So the output type and output value must be known, so that I, as a type interferencer, know if this type and value is consumable by me. They're the beast. If I try to combine now, to compose different functions, even if they're in the same way typed, int to int, completely easy. I have to write a lot of type information in this way if I'm using the compose way of composing functions. And this is just ugly. So I have this compose, and I have to declare all the type information, then the lambda expression, then the same and the same. What I can't do is this gray thing, this component x plus 10, x plus 5. Okay, that's not possible. So type interferencer will just say no, because he is not able to identify what is the input type. That's ugly. Then I played around. So what I'm showing now is only for playing around. Never use this in production. Please never use this in production. Okay, how I can get rid of this type definition. I thought, damn, it must be possible that I have something sweet like compose, 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 and just adding these lambda expressions. Is this possible with Java? And this is the result of it. And this is a higher compose. And this is just, to say the truth, it's possible, but it's completely crap. Huh? It's unmaintainable. So what's going on here? So I have a function, and this function is transferring a function from U to V to a function that is able to deal with a function from T to U and transfer it to T to V. Okay, even spelling this is just amazing. Okay, what I need is I need a function that is able to transfer a function that is able to convert functions. It's the definition. I don't know how to express it. So look at the code. But even if you're doing this one, this higher compose, the only thing what you have is you have this higher compose, and here you have exactly this one. So a function that will get a function as input, and a function that is able to transform the function A and B. This is a huge signature. But you have this higher compose. Okay, good. How to use it? Do we really win something? If you're using this one, then you have this apply, apply, apply. This is working now. So this is really just the lambda expressions. But the disadvantage of this one is you need this static approach. You can't use static imports anymore. I will show you in a few minutes why I use this method, the static implementation of this method. But you have to type the function in a way that all the type information is available. So instead of writing it during the compose time, you're writing it just in the beginning, because the type inferencer, you are not getting rid of it. Okay, if you are able to find a shorter way to describe it in a more compact way with Compose, let me know. I'm really eager to know it, but I was not able to find it. So the difference between is that you're pushing all the type information in the beginning so that the type inferencer can use it, so that you have a small declaration compared to the other one. So both ways are just, they are not nice. What can we do instead? We can use and then. It's exactly the opposite approach, because then it's in a way that I'm calculating myself. Now I know my output type and value, and this I can give to someone else. And the type inferencer is now able to deal with this. So if you want to go in a functional way, make sure that you're always using the approach and then, because in the end, for the person that is using your API, it's way easier, because then you can really say functional dot and then apply. Perfect. This is a very compact and easy definition without dealing with all this type stuff. But it's a type safe implementation. Okay, that's an important thing. It's not just smashing it down to object. So if I have now these different functions, the question is, whatever I'm using, for example, function A, compose, or and then, whatever approach I would use. First of all, how to get this instance of a function B or function C, and what's the best place to store it? After different approaches, the most convenient way is if you're placing it inside function or inside interfaces with static methods. And then you're creating this methods, this logical name, and the return value is an instance of these functions. And this is the first thing. So don't declare the function itself. Create, so describe what you need. And this is the next aspect in functional in the functional world. Don't write what you need, but describe what you need. Always describe it. There's a functional way. Describe. It's a transformation. And the first way to describe something is that you're describing how to create this function. Here, return A plus B, and so on. And then make it available so that you can use with the static imports this very short, compact invocations. And then it would look like function A and then function B, brackets, and so on and so on. Okay, now we have a good place to store some kind of function implementations in a stateless way that's reusable and that you're not sharing the same instance. You're creating always a new instance of this function. Well, you have to make sure this in the same way. So I saw sometimes function declared and then shared, and well. Okay, now you have these functions, a good place to use this, and from the semantics, it's a very compact way. Now the next question is, I'm doing with this definition, I have so many words written down, so many characters, and the only difference is +2, +10, +5. Pushing abstractions to the limit. How and describe what you need instead of writing down what you need. I need +2, +10, +5, but I have to describe it, because then I can minimize the implementation as well. So what I need is a function that will give me, based on input value, a function that will use an integer as input value and adding a constant value and giving back an integer value. This is what I need. Okay, so I'm creating a function called adder or whatever, some logical name. And here I'm describing how to create the function I need instead of writing down the function I need. So now I'm on a more generic way. If I start understanding that I declaring the way to create functions, it will open a door to higher order functions all this way and to a huge amount of functional stuff. So I need a function that is based, that will give me based on input value, the function that I want to have based on this input value. Having in mind, this integer can be replaced by a function as well, because an input value can be a function. With generics, you can do a lot of stuff. Okay, let's stay here. So I have now the possibility to grab this adder function and use it for, I need a function to apply 10, I need a function to apply 5 and 2 on whatever. Now I have these different functions and I can start composing this one. Okay, and I can just write it together. So now I have the possibility to be more generic. I found the first template to get rid of writing down what I need instead of declaring what I need, and getting rid of a function and a value. A function is a value itself, or a function, so depends on how you're looking at it. Okay, so the header itself, if you're just writing it in a compact way, is just easy to write. It's not so much code, and then you can use it. And now the whole code with all the typing information is just in this few lines. It's type safe, it's functional, and so on. And you removed a lot of boilerplate code, because now the syntactic stuff is just removed. All this boilerplate code. Compare the first implementation, compare the last implementation. So, and it's straightforward. Okay, so extract the logic. So if you're dealing with functional in the beginning, you have quite often this object-oriented approach in mind. So let's say areas list, you have these different names, and then you are creating a stream, you're filtering for something, and you want to print it out. The next thing is you want to filter for a different character and printing it out. Now I have two implementations, and the only difference between both is this one and this one. How to get rid. So if abstraction, pushing abstraction to the limits, make it as generic as possible. What would be the way? And mostly people that are object-oriented trained start to extract with the IDE, so extract method and all this stuff. And that leads to the following. For example, the consumer could be extracted without print line. Okay, it's there. Then I'm extracting the value. Okay. Then I'm creating this predicate. Yeah, I can extract this predicate. And then I can create my whole thing. Did I reach something? Okay, I have my names, the values. Okay, I'm creating a stream. Okay, I needed to create a stream. I'm filtering with a predicate. The predicate I'm creating. Okay, I got it. And I'm using print line 2 times. But now I need 2 predicates, the predicate for the first value and the second value. Because, yeah, the piece is here, this final, because I need this final values if I want to use the lambda expressions. And then I have this instance. Okay, so what we learned a few seconds ago, describe what you need instead of writing down what you need. So if you're using this extraction possibilities of my IDE, it's mostly write down what you need instead of describe what you need. So we want to get rid of this final, and we want to extract it in a little bit better way. So the first thing is I'm creating, or I'm describing what I need. I need a predicate based on an input value. This is what I need for this. And this is a function, it's a transformation from the input value to a predicate. And that's exactly what I'm writing down. I'm creating a predicate based on an input value. And the next thing is that I'm now getting rid of this final stuff, because the definition of this getting final is inside the definition of the lambda, and it's isolated because it's just a value. And then I'm creating this instance, this value is combined, and so on. So now what I can do is I can create now exactly one time. The source will be a stream, will be filtered based on an input value, and then printed out. So I extracted all the code, and the only difference now is if I'm invoking it twice, the input value. And all the other stuff is now extracted in a generic stateless way. Perfect. Okay. So this is a difference between I'm extracting with the IDE and I'm describing what I need. Okay, so by the way, if you have any questions, I think the comment section is working, so we'll see it at some time. Maybe I will give with a delay a little bit later the answer, but if you have any questions or comments, just write it down in the comments, please. Okay, in Java, we have here the thing that we have is by functions. We have input A, input B, and this we can transform in a function that is then curried. Why do I need it? I need it, first of all, if I'm coming from the object-oriented world, I have method signatures with different input values, so I have to deal with this, and I want to go into this function world. Then I have to deal with by functions anyway, because they are part of the JDK. So what's currying and why should I use it? So currying means that the core functional approach is one input value, one output value. If I have now 2 input values, what should I do? So the not nice implementation was a by function or try function or whatever function, grabbing all values, transforming it, giving it out. Okay, if you want to make it in a more functional way, so that you have one value in a function, next value in a function, then this is called currying. So reducing the order of the function from 2-dimensional to 1-dimensional. And this is just using the function and invoking it twice. So invoking the first function, invoking the second function, you have both values and then applying the original one. That is currying. And the nice thing is you can uncurry in the same way. Thinking about if you're making functional stuff, making it in both ways, positive and negative. If you're currying functions, because you want to use it, I show you why we need currying. Then you need a way to uncurry a function, because if you're transforming a by function in your world, transforming it, because if you're currying, you have it immediately just a function with one input value, one output value, and then you can use and then and all this stuff again. So this is a need for currying a function. But if you are done with this and you have your final function, for example, then you want to make a by function back because this API needs a by function, or you want to give this instance back or whatever. So you can do it in both directions. You can curry and you can uncurry. Okay. If you have this one, the next thing is I have to deal with more than 2 input values and method signatures. Maybe my legacy code with 2, 3, 4, 5. Then you need a try function, a quad function, and so on. And if you want to create it by yourself, just follow the guidance from the JDK. They have this by function, but they don't have a try function. But you can create it in exactly the same way, okay? And just copy and paste the by function and add one type. Now I have a try function. Can I curry it and uncurry it? Yes, exactly. You can curry and uncurry a try function. You can curry and uncurry about a bunch of dimensions. And that's the nice thing. And with this, you're supporting all the long method signatures from the object-oriented world. You can transfer it in your functional world. You can work and you can offer this back. And then curry function and uncurry function. It's exactly the same. Collecting a value, and then applying the function. Okay. Why should I use this? In the functional approach, what you're saying is that value is created once. If you have a function, you're putting a value in, you're creating something, you will get exactly the same output. Most people thinking about if I'm putting an integer in, I will get an integer out. Okay, then 2 in, 5 out, 2 times, 2 in, 5 out. Okay, it's the same. But what is with your own classes? You have your own business logic. So if you really want to go functional, means that if you're putting the same input value in and you're creating a car, an instance of a car, you're not creating a second instance with the same values of a car. You want to give exactly the same instance back. This is called memoizing. What we are doing with memoizing? With memoizing, it's something like a partial caching on functional level, because I start remembering my values, sometimes useful, sometimes not, so implement it in a way that you can add it to a function as a functionality and you can remove it from the function, this functionality. Don't implement memoized functions in the same way you're creating unmemoized functions, because this is a cross-functional thing and you can add this functionality, this transformation to a function and can remove it. I will show it. So what's going on here? It's just you have a function, and with this function, you're wrapping it with a concurrent hash map based to this instance of a function, because you're just thinking, okay, before I'm calculating this stuff twice, I'm checking in this concurrent hash map, do I have that input value? Have I calculated it already, taking this value again, pushing it out, otherwise calculating it and pushing it to the concurrent hash map. Now you have the possibility that in function is able to memorize values. So, and if you have a computation heavy thing, it could save some time. On the other side, you have some memory issues. So memory issues in terms of consumption. So it's a trade-off. You have to decide not everything is memoizing, it's good. But can we do it with by functions and try functions? Yes. Why? Because if I have a by function and I have this functionality of memoizing implemented in this generic way, I can use this by function. I can curry this by function into a curried function. And then on every level of this curried function, I can add some memoize functionality, yes or no. So if I have a 2-dimensional function, I can add memoizing in 1 dimension, but not in the second one. Or I can add memoizing in 2 dimensions, and I can remove it. And that's great. So now I have the possibility to play around with caching or some kind of caching. I don't want to name it caching. Caching implies so eviction algorithm and all this stuff, but this memoizing, yes, but on a functional level. How it's working, it's just memoizing and back to the function. What you're doing is just this memoizing on a function, and if you're doing it on different dimensions, you're doing it just dimension by dimension by dimension. That's it, and you can do it reverse. So that's a good thing. Okay, so yeah, I think this is a lot of source code here, and if you really want to understand and playing around with this memoizing, check out the source code on GitHub, then playing a little bit around. But the nice thing here, what I want to show is you have something that is very generic, the possibility to memoize. And if you're doing it in a function in a very abstract, generic way, and just reduce on the possibility for a single function, one-dimensional function, you can use this mechanism to do it on higher order functions. So, and this is one thing in the functional world. So solves the challenge for a one-dimensional thing, and then reduce the dimensions if you have a multi-dimensional problem, solve it in one dimension, and then going back to the multi-dimensional thing. So that is, if you have a bifunction, make a correct function, is one dimension, then add memoizing, and then go back to the bifunction. And this is one of the really powerful concepts of the functional approach. If you're extracting just a transformation in a very generic way, pushing abstractions to the limit. It's working with a try function, it's just one invocation more, and quad function, and so on and so on. So now we have no challenge in mapping and code from object-oriented world to functional world and back, even if I have a bunch of stuff. But memoizing, you can do some fancy stuff with this. Okay, let's assume you have this legacy class and you can't touch this legacy class. Okay, it's third-party code, or it's written from your boss and it's untouchable because it was part of his PhD or whatever. So it's just don't touch this code, whatever reason. And you have this legacy class, and there's this do work, int A, int B, doing some stuff, giving a string out. Okay, so, but I have this functional world, and I want to add my functional cool stuff. How can I deal with this? I have this new function, and maybe I have this bifunction that is consuming two values and transferring it and giving it back. Okay, so how to combine this? What you can do is you can have this instance of this legacy class, for example, and then look at this, the line down here, this final bifunction, integer string do work equals my legacy class, double point, do work. What you can do is, even from an instance, you can grab the method reference, and this method reference is bound to this instance. And why can I associate, or can I assign this my legacy class double point do work without any typecast to a bifunction from int to string? The answer is quite easy, because if you're extracting this this method reference, it will be in a way that the type interferencer will just do the same with a bifunction, and you just need the same types. So here the method signature from do work A is int A, int B, return string. From the bifunction, it's input int, return string. So you can convert it, so you don't need a cast anymore. So with this approach, what you can do is you can grab the method reference. Now I have a function. Then you can work in a functional world with this, at memoizing, currying, uncurrying, composing, whatever. And in the end, you can just give it back, because you're not changing the instance that you're using. You're just grabbing the method reference. Okay. So even if you have object-oriented code you are not able to touch, you can transfer it with this approach quite easily in your functional world, and then you can reduce the dimension, you can work in function, and then you're going back. Okay. So this is the code, my legacy class, extracting method reference, and then adding memoizing. Now, what I've done for this method do work, I added caching for a legacy implementation without changing it. Okay, good. We have different possibilities to switch. So in the functional world, I've input, output, that's it, how to deal with branches. If I'm looking at this Core Java stuff, I have the switch, I have if then else, I have this other constructions with this asking signs, and so on and so on. And so tactically, we have difference between the different JDKs, but what approach I'm using here, it's not nice, because I have this huge tree of maintained things. So what can I do in a functional world? What I'm doing here is that I'm reducing this tree of decisions to a linear list of decisions. This means that for every path in my tree, I have a combination of input values and a decision I'm active or not. If I know that I have this decision based on one or multiple input values, then I can transfer it in a linear list of a supplier that is giving a Boolean, yes or no, and then the transformation that should happen. So the first thing, the supplier that's just giving back a Boolean is nothing else as a description through the path and saying, okay, now I went 2 times left, 2 times right. I know this value and then this and if and else and bigger and smaller and whatever. And then I just need to know, yes, I'm responsible for this, or no, I'm not responsible for this. And if I'm responsible, I need the value. I need the supplier for the value. And this is nothing else as the calculation itself. So with this approach, what I can do is this breaking this if then else trees into a linear list of decision and calculation parts. And I highly switch between this stateful stuff to a declaration of just a transformation and just a definition of decisions. So if it is, and then if nothing is true, I have a default case. So if no one is responsible, this is a default thing that should happen. It could be a, I don't know, failure, or it could be a default value, or whatever you need. So what you have is all the definitions and the default value if nothing is happening. So, and with this, what can you do? You can just use all the definitions you are applying with this match, and then you have this default case, and then a list of different combinations of values you want to check. And then you're going over the stream of matches, filtering as long as you find someone who's responsible. If yes, you're calculating the result. This you are doing only once, or else you're using the default case. Straightforward. And what you will get with this is the possibility, if you use a long expression, that you have this case that is now matching, and then you're creating a match case with the default, there's a default value, and then, okay, if the value is A, then do this. If the value is B, then do this. This equals can be a complex mechanism. This could be a complex decision. And if you're reducing the syntactical stuff, then you will see that you can break it down to this match and then match case. First, second, third, and so on. And then you're just describing what is the input state that is necessary for this particular definition or calculation. And then you have a very clear maintainable list instead of this huge if then else branches. Okay, I think this is a little bit complex to understand without playing around with this code, but in the end, it's just decide what you want and describe what you want to calculate. Okay, with streams, a stream is active after creation. That's something that I don't like, and I want to define a stream without starting it, because maybe I'm waiting for something from input value and from the UI and all this. So maybe I want to create this stream interactively. So what can I do? We need a function, right? We need a function that is able to create, based on an input value, a stream. If I have now, for all different variations to create variations of a stream, I have my functions and I have an input value, then I can start composing the function. And the final function is something that you are having without creating the stream. And then later, if you have the value that is creating the stream or influencing the creation of a stream, then it's coming, and then you're creating the stream, and then it's active. So what you have with this is you're decoupling the creation of the stream and the definition based on interactive, and you can define it in a different order. You have no strict order of defining a stream anymore. And then you have the definition, I need a stream that's created based on this input values. This definition you have, but later, if you need this, then you're creating this instance. And this is a huge thing, because now you can play around with definitions and using the streams. Now we have understood that we have the streams, or we have these functions, and we can compose it, we can query it, we can memoize and other things with all this stuff, how to make now this reactive part. if you want to go a little bit further with going reactive, the first thing is we have to think about an observer. An observer is just a concurrent hash map. What you have is a key and a consumer based on value, and then you can register and unregister. So I'm putting a key, I'm putting my consumer. Okay. And if I'm sending an event, what's going on? It's just going to all this registered events, consumers, and giving this value once in. Okay, for this, you have to think about immutability. So if you're changing inside this consumer the value and it's just pushed to the next one, then it's not working. So you need some kind of immutability for sure. But the concept is quite easy. I have transformations, different transformations, and I have one place where I can say, I'm a transformation. By the way, if you have value, just invoke me. Perfect. The observer, very easy thing. Now we have to play a little bit around with the syntactical stuff. Yeah. So. Okay, this is how it looks like if you're using this one. So you can use observer, for example, if you have a graphical interface and you want to have different input fields combined or some calculation. So if I'm adding one here and one adding here, then something's calculated. So you can use these local observers very easily. It's just a few lines of code. And you can register and unregister, sending event and so on. It's working easy. So then the next thing is I want to make sure that this registration and unregistration is easier because I don't want to hold the keys to make sure that I can get rid of this implementation and unregister and all this stuff. So it's called registry. It's more or less the same like an observer, but around an observer, you have this registration thing. What you have is during the time you're creating a registration and unregister this one, you want to make sure that you are creating something to get rid of this key 1, key 2, and so on. Only if you want to have an observer that is based on an address sending values to consumers. So if you have one observer that's not only all registered will get the value, but you have, okay, just for this stream or for that stream, but I would split it up. So what we need is some kind of remover, and this is called the registration. So it's just this method remove. And if you have this observable, what you're doing is that you are just using the key or default key, you're adding the consumer, and then during the time you are add this key to the listeners, you are using the same instance of key to create this listeners remove as an Lambda expression and giving this one back as implementation of a registration. So everywhere, if you're somewhere, you can just say, okay, remove myself. So it makes code a little bit, smoother or easier to maintain because you're not dealing with the keys. You're just saying, okay, get rid of me. So remove me. And so with this, even with this few lines of code, what you can do is just you can now decouple the invocation from the calculation because you are sending something, it's doing something, and then it's happening. And then what I'm doing is that I now think about how to make it more complex. How can I build a chain of these things? Okay, how to scale, how to make more complex things. And this implementation I showed here is easy for graphical user interfaces or UIs or just tiny concatenation between different things. Okay. And so this is not needed anymore because I have this observable with a registration. Okay, I spoke about this one. Now I want to make it a little bit more complex. And instead of building more complex observers, I have this already in my JDK. Okay. So in this JDK is what I have is it's not a process, it's not a thread, it's something like a fiber. So it's something that is a computing unit that is thrown in a bunch of threads. So I have 10 threads and maybe 100 fibers. I'm just pushing this things I want to calculate, I want to do in the thread pool, and then the thread pool itself will decide in which order and what resources will be used to calculate this stuff. Okay, so I'm getting rid of this threads implementation and this management of threads. That's not easy. And this is more or less this completion stages from the completed future. Okay, so how to work with this. And if you want to understand it a little bit more, it's the API of Complete Future is huge. I don't know, 50 or 60 methods, and but it's really cool to understand. So really dig into the JDK and just read it a few times to get a feeling about what this Complete Future can do. It's amazing. So what we have this executor service. Executor service is this holder that is defining what resources I can use. First part. This will be decoupled from the amount of work. So I'm defining, okay, this one. By the way, Heinz Kabutz had a very interesting blog post about this method, available processors, with hyperpath threading and real cores and all that stuff. But just side note. So this executor, I'm now creating a fixed thread pool. So it means I decide 5 threads, okay, or 2 or whatever. Now I have this executor service. On the other side, I want to decide what's the amount of work or what's the definition of work. So now I say I have a supplier. I'm just creating a string or grabbing a value or connecting a database and grabbing something, whatever. If I want to connect now this task, what should I do with the pool I have where this work could be done? I use this Complete Future method supply asynchronously, and I'm combining a task, what should be happen, and push it into a pool. And I will get back a Complete Future typed on the input value. And then I can just wait until it's done. I have different methods to do this here, but what I'm using here is then accept asynchronously system out print line. So what it means is it will wait until this creation is done. Here it's just creating a string. And then it will use a consumer here that's push with then accept asynchronously. It will write down on the screen. If you want to end it, then result join. You have to wait until it's done. And if this is done, you can shut down the pool. Okay, because work is done. So pool shut down in the end of the program. Don't do it after every task. Makes no sense, but you have to shut down. Otherwise, termination of the JVM is a little bit creepy. Okay, so use fixed thread pool with some kind of processors. You have to decide if it is CPU intensive, network intensive, IO intensive. Then you can dimension the pools you have for this dedicated work. And then you can, with static import, remove this, supply asynchronously, pushing a lambda expression, then defining what should happen with a lambda expression or method reference, and then say join. That's it. If I'm looking at this, I see a few things I saw before in this talk. These lambda expressions, these are functions. This consumer is a method reference is some kind of function. Oh damn! Now I can start combining this. That's cool. Okay, assume you have a value A, value B, and you need these 2 values to calculate something. Okay, an operator. Then this result will need a 3rd value, value C, and then the operator can calculate the final result. Okay, so, but the challenge is you don't know in which order value A, B, and C are coming. You don't know it. No idea. Network, JDBC, whatever. I don't know. Interactive, no? So input value from UI. But I know I have these operations based on values, and I need an order of these functions, operator A and B. Okay, so, and I need a result, and I need the information if something is going wrong, so that I know, okay, something is going wrong. If you want to deal or want to write this with threads, the source code is huge and not nice, definitely. But with this here, I'm creating this fixed thread pool. Okay, I have this executor pool. Now I'm creating this Complete Future. Okay, step A, step B, step C. I'm creating this value, so I'm grabbing the value from somewhere. It's more or less defining a asynchronous supply. And then I start to combine the steps. If I have the value A, then I combine it asynchronously with the value B. Okay, value E, value B. And then I have this operator 1. A and B will be the sum of A and B. Okay, if I have this one, this is a step A and B, and then the sum of it. Okay, for this I'm waiting. It's a Complete Future. Okay, the next thing is I want to combine this step A and B with a value from C. Okay, C can come somewhere. Step A and B is maybe ready or not, but I have the transformation that I'm adding A, B, and C. And then I wait until it's done and printing the result. Okay, now I can wait a long time for A, B, or C, but I can define the transformation because I'm combining the flow, the tree of information here. But how can I make it nice? So if I see this piece of code, so many boring parts in and so many repetitive things, and thinking about pushing abstraction to the limits and this functional approach and what's stateless and what's stateful, damn, so many things I saw already. Okay, what can we do? I want to write this a little bit smaller, supplying asynchronously with A, with B, with C, and I'm defining different pools. I can put different pools for different combination steps. So if I use the first executor and assigning to pool A, I can use the second complete future to assign to pool B. So I can even switch workload between pools if I'm defining one chain of complete results. That must be clear. Okay, so what can we do? I have the challenge that a complete future is active after I created it. That's the first thing I don't like. Maybe I want to create this full chain of things in an asynchronously way, and the definition where should it run, I want to create it, but I don't want to allocate the resources. Or maybe I don't know if the full definition is done because I'm waiting for some interaction from the user. So how to make sure that I'm dealing here with this stuff? I see that my transformation here is, I think it's here, it's the source. The source can be a supplier, so it could be a function. And the next thing is that the function itself is A plus B. It's just a function. So I'm extracting this one. If I'm now adding all this stuff together, I'm extracting the functions and the static imports and all this stuff. The whole chain I'm creating here, value A and B, an operator, value C operator, and so on. This is this tiny amount of code. With this, I'm describing now the whole chain without adding the values itself, if I'm extracting the source values, okay? But with this, I can describe now the whole thing. Okay, now functional world is so great. Okay, now everything is functional. And I learned a lot about object-oriented stuff. Now I'm throwing all this away because I never need it again. No. Makes it sense to combine these worlds? Definitely. The real good power out of Java you are getting if you're combining the object-oriented world and the functional world. If you learned already something inside the object-oriented world, then use it. Just use it. I will give you an example. A complete future is active after creation. I want to get rid of this one. Okay. I want to define a complete future without starting it. So I want to make it an interactive queue of things or whatever, something that's happening. And then I want to decide what's the right time to allocate all this stuff. And for this, surprise, surprise, I need a function. Huh? I need a function that will give me the possibility to put an input value in and create out of this a complete future. Okay. Let's think about what can we do. If I have these functions, step 1, step 2, step 3, to uppercase, adding some text, stupid stuff here, but I have different functions. Now I want to combine them in a reactive way. What I can do it manually. I can create this complete future with values and I'm supplying this stuff and so on. If I'm looking at the source code, just to concatenate these functions in an asynchronously way is way too much. Definitely way too much. And it's ugly. It's ugly code because I'm just rewriting always the same stuff. It would be nice if I can do it like this. I have something that is defining the first step and then combining asynchronously different functions. And now this one, I'm creating the final functions, the description to create it. And then later, if I have my value, then I'm applying it and I'm waiting for the calculation. Great, now I achieved all the things. I'm just using my functions, I'm composing this stuff, I'm connecting at places where I want to have this asynchronously breaks. If I want to have non-asynchronously breaks, then I'm just creating a combined function as input value for then combine asynchronously. Okay, so I have the full control. What part is asynchronously? Where is the pool? And what part is blocking? Cool. And I'm not allocating resources. because the time to allocate resources is in my hands, because I say, now apply this function to create this completely future. For this, I'm creating the completely future queue. If you're looking at this source code, what you will see is this private folder result function, this possibility to create an initial thing here, this result function. Okay, this define methods, a static one, define, then it's the first input value. I'm creating the first complete future. Okay, then I have this then combine stuff, and then it's pushing all this stuff together. And then I have a method that will give me this function. This is a builder pattern. That's a boring old object-oriented builder pattern. And with this object-oriented builder pattern, I can just create now my stuff I need. Okay, so that's just cool. And with this, I can create exactly this syntactical, nice to use thing. So don't ignore the object-oriented world. Use all the design pattern you learned already, but combine it with the functional world, extracting it in a way that you have the transformation and the value not mixed up. You can switch from the object-oriented world to the functional world if you're using this approach of currying, uncurrying functions. You can add cross-functionality with like this memoizing. Even with legacy code, you can't change because you can go over this method reference in your functional world approach. You can transfer it and then you can go back. Okay, so many things you can do now. And I think this is a huge thing you should think about. It's a huge thing that is a big weapon, and the source code of all this I showed you is just I don't know, a few hundred lines of code. That's it. If you don't want to write it by yourself, go to my GitHub repository. Function-Reactive is the repository. Or just ping me on Twitter. I will give you the URL, or LinkedIn, and feel free to connect to me. And if you want to have more stuff about this one, check out my YouTube channels. I really would like to see you as my new subscriber. But if you want to do it with hands-on and you really want to have a workshop, just let me know. Then we can organize maybe a workshop, maybe remote, or maybe a little bit later in person. And I would be more than happy to see all of you in real life someday, so that we can sit down for a few hours and do all this with hands-on. Okay, so checking here some comments. Yeah, thank you very much for all these nice words. And I can say thank you very much for attending. If you have any questions, feel free to ask me. Come to me via social media and all this stuff. The only thing I'm really bad in is emails. Emails is just horrible for me, okay? So if you're writing email, be aware it could be that you have to write it twice, okay? Because email is just unbelievably bad with me. But Twitter and Facebook and what else, I'm quite responsive. Okay, so is there any question? I will check the chat now, the comments. I will wait. I think there's a little bit delay, so I will wait here a little bit. So if someone is asking something, but otherwise.
Yeah, I can't really see any questions. I just saw, a comment like that.
Yeah, thank you very much.
Which is actually pretty true, I think. It was so many information. Yeah, it's great. Okay.
Okay. Yeah, cool. So well, if you want to have in hands-on, just let's organize an live hacking, and then we can code together. Then we can do all this stuff in a practical world and play around with this. Huh?
Sounds
so
great.
Feel free.
Hopefully we can do it like on site when we go back to normal.
Yeah, let's say September, August. Yeah, September. I think should be warm enough so that COVID is not aggressive. Huh?
Exactly.
Let's see. Or June maybe. Let's see. Okay, so just feel free to organize, and yeah. Otherwise, just ping me. Huh? You have my coordinates.
Yeah, thank you, Sven, for being with us. This was a great presentation. Yeah, I hope to see you soon.
Yeah, definitely. So let's organize.
Participating. Bye-bye.
Okay. Bye.